Math 3, Unit 3, Section 2. We're continuing talking about graphing polynomial functions. Okay, I'm going to reference this equation right here as I go through each of these basically like definitions. Okay, so to find the degree of a factored polynomial, we add up the degrees of the factors. So on this problem right here, -3 is a factor, but there's no variable there. So that doesn't have a degree. Does that make sense? Okay, on this factor, what is the degree? 1. On this one, what will it be? What will it be? 3. Does everybody agree? Because this really has a 1, but there's 3 of them. Okay, so that means it's going to be 3. Okay, so 3. And then on this one, again, here it's a 1, but there's how many of them? 2. And so we add those together, and this degree is 6. Any questions on that? Are we confused on this being 2 or this being 3? Okay, next one. To find the leading coefficient of a factored polynomial, so leading coefficient, multiply the leading coefficients of the factors. So this is a coefficient, this is a factor, okay? So you have to multiply the -3. Okay, on this one, what's the coefficient here? A 1. There's a 1 in front of this x. Do we all agree with that?
Yeah.
Okay, there's a 1 in front of this x as well. Okay, so this 1 is right here, is this one. Now on this one, I'm going to go ahead and raise it to the 3rd power because there are 3 of those ones. It's going to change if that was a number or a negative value. We know that 1 to the 3rd power is just 1, but I want us to write down so we see what's happening, okay? And this one, what is the value? -1, but that one is going to be to the 2nd power. Okay, anybody confused by where these numbers came from? Okay, so now we're going to multiply this together. Well, when you're multiplying these numbers, you need to take care of exponents first. And so I still have -3 times 1, and then 1 to the 3rd power is 1, and -1 to the 2nd power is 1. And when I multiply all of that together, what do I get? -3. And when we're talking about leading coefficients, I found that it's -3, but the most important part about that is that it's what? That it's negative, okay? All right, any questions there? All right, this next part is to find the y-intercept. Let x equal 0 and solve for y. So in this problem, and I'm just going to this information right here, that was for our lead coefficient. Okay, I'm going to do this here for my, sorry, this is supposed to be y-intercept. So to find our y-intercept, all we're going to do is plug in 0 for our x's and solve for y. Over here, what you can't see, it says y equals. So y equals -3. So I'm here with this equation, okay? -3, but I'm going to plug in 0 for x. So that means I have 0 minus 1. On the next one, I have 0 plus 2 to the 3rd power. And then here I have 3 minus 0 to the 2nd power. So all I did is I let x equal 0 in this equation, and I'm going to simplify, and I'll get an answer for y. Okay, are you guys ready to simplify? So as we go through here, I still have -3. 0 minus 1 is what? -1. 0 plus 2 is what? 2. And then 2 to the 3rd power is what? 8. So I'm doing 2 things right there. I hope that's okay. And then 3 minus 0 is 3, but 3 squared makes 9. Everybody good? We multiply all that together. Negative 3 times 1 is positive 3. 3 times 8 is 24. And 24 times 9, anyone? 216. Okay? I didn't do that in my head. I'd already multiplied it out, just so you know. Okay. Anyways, so y-intercept, that means we plugged in 0 for x, and we got 216 for y. That is my y-intercept. Okay. Are we good? All right, the next one says x-intercept of a polynomial, if one exists, is that you will let y equal 0 and solve for x. Notice on this next one, it says to find the roots of a polynomial, let y equal 0 and solve for x. To find the zeros of a polynomial, let y equal 0 and solve for x. What do you notice? All of these have the same definition. Do you see that? So what that means is when they're talking about x-intercepts, when they're talking about roots, when they're talking about zeros, they all mean the same thing. Okay? So how do I find either the x-intercepts or the roots or the zeros? What do I do?
Y equals 0.
Let y equal 0 and you solve for x. Well, what happens here is that basically each of these factors you just set equal to 0. Okay? So when it's in factored form, it makes it really easy to find your zeros or your x-intercepts. And I'm running out of room here, so I'm going to end up writing my x-intercepts right here. Okay? So I set each of those factors equal to 0. Let's just rewrite this problem here really quick. Y equals negative 3. We have x minus 1, x plus 2 cubed, and then 3 minus x squared. So for me, when I am doing these problems and it's already in factored form like this, I just draw the lines down and I set each of these factors equal to 0. When I set negative 3 equal to 0, can I solve that? No. So this is not an x-intercept. It's not a 0. That doesn't exist there. On this one, and I'm going to set x minus 1 equal to 0. So what would I do to solve there? Add 1 to both sides, and we get x equals 1. This really represents an ordered pair, which is 1, 0. We plugged in 0 for y, and we solved for x. Okay? On this one, we set x plus 2 equal to 0. To solve for this, I would subtract 2 to both sides. We get x equals negative 2, and as an ordered pair, that would be negative 2, 0. This last one right here, 3 minus x equals 0. Now, we want to get x by itself, and we want x to be positive. So what would be the easiest thing to do on this problem?
Add 9.
Yeah, add x to both sides. And so then you would get 3 equals x. 3 equals x and x equals 3, same thing, right? And so as an ordered pair still, this is 3, 0. Is anybody confused by any of this right here? So these are all my x-intercepts, or my roots, or my zeros. I'm going to put right here, x-intercepts. Okay? Slash roots, slash zeros. That's what all of those are. Okay, there's one more. Yes?
Why don't you put the exponent in?
Say, wait, one more time.
Why don't you put the exponent in?
Great question. If I put x plus 2 3 times, because that means that there are 3 x plus 2's, I'm still going to get negative 2 each time, correct? But that's going to come into play for our last definition that we have today, which is dealing with multiplicity. Okay, multiplicity is when you're talking about something that you have multiple times, the same thing multiple times. Okay, so if your multiplicity of the x-intercept is odd, then it passes through the x-intercept. Okay, and I'm going to explain all of this in just 1 minute, but one more here. If the multiplicity of the x-intercept is even, then it bounces, which means that it touches the x-intercept. So that's going to what Devin just talked about right now. See here, x minus 1. How many x minus 1s were there in this equation? How many x minus 1s were there? There was only 1, correct? That means that this has a multiplicity of 1. And is 1 odd or even? Odd. So that means it's going to pass through the x-axis. Okay? So I'm going to put a P here to let us know that it passes through. If you're looking here at the graph, do you see how this is like passing through this point? That's what they mean by passing through. Okay? On this one, the x plus 2 to the third power. How many x plus 2's are there? 3. So this has a multiplicity of 3. Because it's to the third power. There are 3 x plus 2's. Okay? Now, 3 is an odd number, so it passes through. On this one, this has 3 minus x squared, which means it's going to have a multiplicity of 2. And if it's even, it means it bounces. Okay? Bouncing means it touches the point, but it doesn't actually go through the x-axis. So this is a bounce. It's almost like makes a parabola, or, you know, it's just touching it and turning around. Okay? It makes a maximum or minimum value at a bounce. Okay. So all of this information is going to help us graph. Okay? So we're going to go ahead and do one of these right here, and we're going to talk about finding the degree, the leading coefficient, do everything I just showed you on this example right here. Okay? So, starting here with A, and then on the back side is where we're going to actually graph them. Okay. So, degree. What degree does this one have? So, the degree, is there anything? Are you just hanging out? Or?
Oh, no, I would love to hang out. I just think to ask Mr. Greer a quick question.
Okay. You can step outside, sir. Okay, degree. What's the degree of this first factor? 2. What's the degree of this factor? 1. What's the degree of this factor? 1. And what's the degree of this factor? We add all that together, and my degree is what? 7. Okay. Your lead coefficient, okay? What is the coefficient of our first factor? 3. What's the coefficient of this factor? 1. What's the coefficient of this factor? And this 1 is coming this one here. That was that one there, so that's 1. And what's the coefficient of this factor? -1, but this one is to the third power. Okay, so we multiply all that together. Okay, -1 to the third power is actually what? -1. So 3 times 1 times 1 times -1 makes -3. And the most important thing about that is what? It is negative. Okay? Based on this information, what is my right end behavior? Negative infinity is correct. Why is it negative infinity? Because my lead coefficient was negative. What is my left end behavior? Positive infinity. Why is it positive infinity? Because my degree is odd. Any questions here? Okay, next we're going to do our x-intercepts with multiplicities. So I'm going to rewrite my equation right here so I can draw my lines and do each of my factors. So I have y equals 3x squared, parentheses, x minus 5, parentheses, x plus 1, parentheses, 2 minus x cubed. Okay, I'm going to draw my line down for each of these. Does anybody know when you put 3x squared equal to 0, what does that equal? 0 is correct, but I'm just going to show you why it's 0. First, to get x by itself, you would divide by 3. Okay, 0 divided by anything is what? 0. And then if you take the square root of a 0, guess what it is? It's still 0. So x equals 0. What is this multiplicity? This multiplicity is 2. And because it's an even number, that means it's going to bounce or pass through. Bounce. So I'm going to put a B to remind me that it bounces. The multiplicity was 2 because this was to the second power. If this would have been to the third power, it would have been a 3. So your multiplicity comes from how many factors are there. Okay, so this one really is 2. Yes?
So is it an factor no matter what, it's just 1?
Unless there isn't an x there. Okay, so you're always looking at the x.
Okay.
Okay, so remember on this one, like right here, it just had a -3. Well, that doesn't have anything. Okay, all right. So on this one, x minus 5, if we go x minus 5 equals 0, what does x equal? 5. You add 5 to both sides, x equals 5. Can we skip some of these steps? Like we know x minus 5 when we set it equal to 0 actually equals 5. Okay, so I'm okay with you skipping some of those steps. What is this multiplicity? 1, and does it bounce or pass through? Pass through. And don't forget that this is really an ordered pair. This is really 5, 0, correct? This was really 0, 0. Okay, x plus 1, when you set that equal to 0, what does x equal? -1. So this ordered pair is -1, 0. What is this multiplicity? 1, and it means that it passes through. Okay, odds pass through, evens bounce. Okay, on this one, 2 minus x equals 0. This one, sometimes you might have to think a little bit more, and so you might actually want to show your work by adding x to both sides. I end up getting 2 equals x, so that ordered pair is 2, 0, and this has a multiplicity of what? Which means it passes through. Okay, questions there? All right, y-intercept. Who remembers how to find the y-intercept? Plug in 0 for x. So we're using our equation, okay, which I rewrote right here, and I'm just plugging in 0 for x. So I have y equals 3 times 0 squared. I'm plugging in 0 for x. Times 0 minus 5, again 0 for x. Times 0 plus 1. Times 2 minus 0 cubed. When I simplify this, I get 3 times 0 times -5 times 1 times 8. 2 minus 0 is 2. 2 cubed is 8. What is 0 times anything? 0. So this y-intercept is 0, 0. Okay, are we okay there? We would do the same thing here. I don't think we need the extra practice. We're going to move on. Okay, we're going to move to the back. Okay. We're only going to do one of these examples. Okay? I have to move a little bit fast. Okay, what is my degree? 3 plus 1 equals what? 5. Lead coefficient. There's a -1 here in front, and then 1 to the third power, and then this is a -1, and this is a 1. Okay? So we end up with -1 times 1 times -1 times 1, which will end up equaling a what? A positive 1. Most important is that we know it is positive. Based on that information, my right-hand behavior is going to happen. What's going to happen with that? Positive infinity, because my lead coefficient was positive. My left-hand behavior is going to be what? And that is because my degree is odd. Okay, now I'm going to set each of my factors equal to 0. I'm just going to draw these lines down here so I don't have to rewrite them. Okay, -1 equals 0. Doesn't make any sense. That is not an x-intercept. Okay, x plus 2 equals 0 will give me x equals what? -2. So that has an ordered pair of -2, 0. multiplicity of what? 3, which means it passes through. Okay? 1 minus x equals 0. That will give me what? 1 equals x, so we have 1, 0 for that point. That has a multiplicity of what? 1, which means it passes through. Okay? X plus 5 equals 0 will give me x equals negative 5. That has a multiplicity of 1, which means it passes through. Okay. Oh, I forgot to write this order pair. That was negative 5, 0. So let's go ahead and mark all these on the graph. Okay? So negative 2, 0. On your graph, down here, negative 2, 0, there's a point there, and I'm going to put a P to remind myself it passes through. Okay, there's a point at 1, 0. So I make a point at 1, 0. I'm going to put a P here to remind me it passes. There's a point at negative 5, 0. I make a point there. I put a P to remind me that it passes. Okay, next I'm going to find my y-intercept. Okay, my y-intercept is where I plug in 0 for x, solve for y. Y equals negative times 0 plus 2 cubed times 1 minus 0 times 0 plus 5. So all I did is plug in 0 for x. I end up with negative 0 plus 2 is 2. 2 cubed is 8. 1 minus 0 is 1. 0 plus 5 is 5. And I multiply all that together and I get negative 40. So my y-intercept is at 0, negative 40. The nice thing about these graphs is that there's no markings on the y, so you just have to mark it, put a point, and say that is negative 40. Now, our end behavior. Right side goes to positive infinity. So on the right, the furthest right point, that is going to go up to positive infinity. Yes. So my furthest right point, positive infinity. My furthest left point needs to go to negative infinity. So this is going down to negative infinity. Since it's passing through, you pass through it, turn around. Pass through it, it turns around at the y-intercept, and it's still passing through. If it had a bounce, it would change directions, okay? And so that is that. Are there any questions?